trying to set everything up. I think that works. Okay. Now, let's go here. Hey everyone, today we're going to go through, I don't know, just some DeepML questions early morning before I start my official work. Let's see. We're going to go through root mean squared error, start off easy, and we'll work our way through it. So set up this little walkthrough. I'm just trying to understand, walk through a simple example, and then code it up. Zoom in. Okay, so root mean squared error. Root mean squared error basically tells us how good a model is. So just for better understanding, I'm going to make a little graph. Let me know if I guess you can hear me and stuff. So we'll assume we have a linear regression case, or so we have a bunch of data points, and these could be, let's say, price. This would be square footage of an apartment. I'm moving soon, so I feel like all I'm thinking about is, apartments and houses. I'm moving to a new apartment, but yeah, I feel like that's all I'm thinking about right now. So we have the square footage here, and we have the price here, so maybe this data's not, because you assume the higher square footage, the higher the price, but whatever, random data. So this line right here is our linear regression model, and we want to know, I guess, how good it is. Like, is this one better than this one, or this one, or this one? I guess it'd be that. But we just want to be able to quantify how good each model is. So our goal basically is, so each point here is an actual, and then this line represents our prediction. So the goal is to just figure out figure out this distance, or then figure out the distance for all of these dots. So for this one, and for this one, every single one, we need to figure out a good method. And the method we're going to go through here, I mean, there's a lot of different methods, is root mean squared error. So we basically take the difference between the true value, so that would be this, and minus the prediction, which would be the line, and we get that value, we square it, we sum it up, and then we take the average pretty much. So I feel like, why are we taking the squared value versus just taking the, why not just the difference, why are we squaring this? And that's just because if we had an error of, let's say, 3, put this here, say that was distance 3, and this was distance minus 3, what would be if we just took the difference, it would be, 3 plus minus 3 equals 0, and this would basically be saying, hey, we have a perfect model. Even though we don't have a perfect model, just the errors are canceling out. But if we take the square of each value, square of each error, that will make this 9 and this 9 and this be 18, which is very high, because that's why we eventually do the square root. Just doing the squared value, I guess the inside is just MSE, mean squared error. Root mean squared error just brings it back into proportion. Well, that's the goal of it, at least. Okay. Oh, I'm not sure. Let's see. Okay. Sorry, just checking on some stuff, getting used to this. Okay, let's walk through a quick example. So here we would basically take, okay, we have y, and we have y pred. We take 1 minus 1, so that'd be for the first value, and we'd square that, plus 0 minus 1, that'd be for the second value, plus 1 minus 0 squared, third value. And this would simply be 0 squared, which is still 0, plus minus 1 squared, which is 1, plus 1 squared, which is 1 again. And this would equal 2, and then we divide all of this by n, so there's 3 total examples, so take 2 divided by 3. I'm thinking about adding, I'd love to hear people's thoughts on this. I think about adding an Excelsi draw option within DeepML, so you'd have, you know, this option, you'd have notebook option, and then theoretically notes option, just for you to be able to take notes. Still need to add being able to save notebooks, and theoretically we might run into a similar issue with Excelsi draw. It would just be, but I feel like that would be annoying, and you probably want to persist your notes for each question, but maybe we could come up with something. But that would be pretty fun, pretty interesting. At least for me, if I'm I feel like a lot of the building I do is just like, hey, I find, this would make my life studying machine learning easier, and then try to implement it. Okay, so root mean squared error, so we have this value, which is basically the mean of, basically the mean of the errors, and then we're just going to take the square root, and that would equal, some number. Okay, I think I have a pretty good understanding of how everything works here. Let's move on to coding it up. I don't know. I feel like I don't need to code it here. Let's do it on DeepML. Yeah, it seems like I did. Did I even mention to round it, or I just? Yeah, I guess just need to round it. Let's see. So RSME results. You're taking np dot sqt square root of, I guess, the mean, because we could basically turn these values, instead of 1 over n times the sum of this, we could just say np dot mean, and take the difference. You have to be very careful with all the parentheses here, so we have y underscore true minus y underscore pred, and all this should be squared. Let me see, make sure everything's okay. I think this is correct, yeah. I mean, well, let's run the code and see what happens. I think it's right, but I could be, nope, we got it, woo. Nice, okay. What time is it? 8:20, yeah, I have another 20 minutes. Let's see what the problem of the day is. Ooh, or maybe we could go through a deep zero question. See what the problem of the day is. Bridge to regression loss. Let's go through deep zero. See if anyone went convert RBG to grayscale. Implement direct preference optimization loss. I don't even know what that means, but it sounds interesting. Vector dot product using NumPy. I think I might be able to do these two. Let's start. See how it is. One thing to check is just to make sure the output is correct, because sometimes you'll see the output as, an error, and you'll know, I guess there's an issue with the question. You probably shouldn't even try to solve it. Let's see. I feel like it's probably hard to see. There's a function that converts. Grayscale. Okay, so our goal is to convert an image to grayscale. The function should take in a 3D NumPy array represented 2D NumPy. Okay, so we're trying to take a 2D NumPy array and convert it from RGB into grayscale. So parameters, you have image. So we're taking an image, which is a NumPy array, a 3D NumPy array with shape, height, width, and 3 dimensions. Let's move over here. We are doing this. So, okay. So theoretically, all images, or I guess these images, I wouldn't say all images, there's a lot of different types, are RGB. So theoretically, each image, sorry, just, so each image theoretically has a red, green, and blue within it, so RGB. So it's 3-dimensional, so in code it would probably look like 1, 2, 3. What would it look like? Let's say. So we're taking in a 3-dimensional thing with, height, width, length, height, width, and the 3 representing RGB. So yeah, it would be a 1, 2, 3, 1, 2, 3. So let's go through it some more. Each value will have, 0 to 255. The last dimension represents, so last dimension, the 3 is red, green, and blue. The goal is to return a 2D NumPy array with height and width, because I guess you're assuming that this will become 1, because, so black and white is, our goal is to convert this into just a black and white. Let's see. So our goal is a black and white image. So RGB. Our goal is black. Our goal is to make basically a black and white image. Let's see. Let's continue. 2D NumPy array with height and width in grayscale. So, okay. The image of the array will data type. Okay. Each up to, okay, so saying the maximum length of an image is 1000 pixels. Okay, so each one could be up to 100 pixels. Let's look at the example to just get a better idea. So, we'll take in, so this is the image we would theoretically take in. Let's see. So, this image, I'm a little confused. I feel like I missed something. The parameter should just be image. Yet in the example we are getting what seems to be okay. Let me reread this a little. 3D NumPy array, height, width, 0, 0 into 55, the last dimension represents, okay, so the last dimension this represents the intensity, so all red, green, and blue are all equal intensity. 255, not sure what that represents. Let me go through the learn section. Or, yeah, let's read through this. RGB to grayscale function, looks in a 3D rotation. Panels for each pixel. It appears that luminance formula. Let's go to the learn section and see what it's trying to actually tell us. Okay. So yeah, so we talked about this. It's basically saying the, you know, RGPIP is made up of 3 main colors, red, green, and blue. Each component represents a level of intensity, typically from 0, no intensity, to 255, 100% intensity, or max intensity. For example, a pixel's colors is defined by the combination values. Okay, let's check on, okay, let's see. Get illumination formula. I guess this is what we're probably actually trying to program. As the grayscale intensity. Weird. I mean, I'm a little confused what this formula is, but I guess it tells you the grayscale intensity. Is that what we're trying to compute? Because then I don't know how well this question did. Because convert RGB image to grayscale, including the function that converts RGB to grayscale image. The function should take into the array. Okay. Right. Use appropriate weighting for color channels to mimic human perception of brightness. I mean, I feel like it should probably tell you, hey, use. Let's continue and then I'll critique it after if needed. But yeah, I feel like you'd have to read the learn section to understand to use luminous, whatever, this formula. Single intensity value based on switch appropriate. Okay. I'm very curious how they came up with these numbers, but it's saying basically that the human mind, I guess green is lighter than red or blue, so it should have a higher, I guess it's the brightness amount. So green they're saying is brighter than red, and red is brighter than blue. Very curious how they came up with these numbers though, because they seem, at least to me, a little random. Maybe we'll look into that after. Coefficients. Standard weight based on studies of human vision. Interesting. I wonder if they like looked at different activations when people look at red, green, or blue, like took them under an MRI and got those values, or yeah, and sort of just turned them into probabilities or weighted values. Okay. For instance, large weight of green reflects green contribution more. Okay, they're saying green is brighter than red or blue. That's why it's higher. Let's take this though and throw it into here, just so we have it. Okay. Okay, the weight in the formula represents Okay. In the case of red influence. Okay, so 0.29 represents how much red, this is how much green, this is how much blue, fine. Yeah, I could assume the value sum to 1, sure the results take. Okay, I think this is important. Okay, this thing, if we use this formula, it should represent humans' perception. But I feel like this isn't telling me how to convert something to grayscale, it's just telling me the grayscale intensity. I mean, I guess here it says containing a grayscale image intensity. Okay, let's continue. Let's walk through this test example they gave us. Consider a simple pixel has intensity of, okay, so they're saying we have a single, so I guess imagine this was a single pixel, and we had an intensity of red at 100, over this, and green at 150, sure, 60, 70, and we have B at blue at 200, I'll leave that as is. Okay. Okay, so they just, substitute all the values, do some math. I don't know. I mean, I guess LM made up this math, so I don't know if it's 100% correct, but let's see. Calculates each term, fine, fine, fine. Okay, so the grayscale pixel text is approximately 141. Rounded for simplicity, fine. Represents the medium shade of gray. Cool. But this is just telling me, okay, maybe I'm being too harsh, I'm being too critical. Maybe it's, okay, so maybe 141 would be the first value in the grayscale image, because this is a single one. The final, I guess we're only looking for one pixel, but if we have multiple pixels, then this would be different. So this would be 141, I think it said. Yeah, 141. So theoretically, we will need to, theoretically, we're going to have some image, and this will be theoretically, no. Actually, hold on, I had an idea. This would be, let's say, whatever, we'll make it blue for ease. Let's say each one of these small little boxes is a pixel, and we have a bunch of pixels. And we want to basically get, you know what, thought I was going to save time, but I think this looks nicer. Let's make it, we will have 4 pixels. Theoretically, all of these have the 3 layers. And we will try to convert, I guess each of these pixels will be converted to our grayscale image. So this is, I'll make this a color just to make it a little more clear. So each one of these will be converted to, a grayscale image. Or each of them will be converted to grayscale, and then we'll have a grayscale image once we have all of those converted. Okay. So theoretically we're trying to convert it, and I'd say this arrow is probably represented by this formula. This is so light now. Arrow is probably equivalent to this formula, and we'll take each value, pass through this formula, and get the grayscale value. Okay. But let's see. I know we have this. Just theoretically the input. So this would be a 3. Huh. I'm a little confused by. I mean, I would understand this. Okay, you know, the first layer is completely red. So this would be red, this would be green, and this would be blue. So it's saying you're having 100% of each. I'm a little confused what this last column is. Hmm. Do I need to enter in a D-type, or is it assumed for me? I guess I don't need to deal with that. Okay. See, it's a 3D numpy, right? And this is... At least it's 3D, not a 3x3. Fine. Last dimension represents the red, green, and blue channels, respectively. But like, let's say this was... Let's say this was 255. Just that. What would that change in my image? We will ask the GPT. Let's see. Throw this here for a sec. Just do it. This actually. Oh, it's quite early. Okay, fine. Okay, red, green, blue. Okay. To just... No, I switched it up. Okay. Okay, I don't think I understood what I was saying. Whatever. Let's try and code it and see where we get stuck. So theoretically, for each value, so notebook mode. For each value, we are trying to. Oh, I guess we're going to use this formula. And okay, so the first value in the array will be red, green, blue. So if I could, and I said this was equivalent to, let's see, so this was equivalent to 0.299, comma, 0.587, comma, 0.114. I mean, it's a solid question by Deep Zero. I mean, just for like completely generated. It's not the clearest, but also not being the clearest makes it a little more interesting to solve. Let's go here. Okay, so these are our Loomis. I don't know. What is it called? So these are grayscale intensities. Okay, whatever. And actually, we'll have an input. Theoretically, our input image will be this. So image. Didn't close that. Our image would be this. Why is there? Oh, okay. I'm even a little more confused now. Saying a little confused by this. Okay, let's see. So we're saying this be one. Let's see. What if under? So this is theoretically what we're looking at. So we have. I mean, I would understand if it was this. I don't know what this last column is. I'd understand if it was this. This would make sense to me. Because then I would say, okay, the first row is red, second row green, and third row RG in blue. But that's not what it's saying it is. It's saying this, which is just weird to me. Did it just make up some of this stuff? Can't tell if I'm wrong or this is wrong. I guess that's the issue with, just generated questions. You don't know who's right and who's wrong. You can't tell if you're going crazy and something's not making sense to you, and if it's actually not making sense to you because it's your fault, or if it's not making sense to you because the model made a mistake. Let's see. Okay, so if I took my Loomis score and dotted it with this, that would give me those I mean, let's see. Let's try that out. But, yeah. Okay, so image 0. So dotted that with the Loomis values. Okay. It seems like that's what they're doing. This is 29 and 128. Still a little unclear. I guess this is just one image. Maybe this is one pixel. And this is a second pixel? I guess that theoretically makes sense. Okay. Okay. Maybe I'm losing it. Okay, so we'll assume that this is the first pixel, and we'll assume that this is the second pixel, and we need to convert it to grayscale. And this would be the grayscale values of it. So, and that also makes sense. Okay, so let's go here. Say for I in. And it's also import numpy. For I in image, I in image, what are we doing? Doing this basically. We should define loom though. Okay, loom is defined. This should be image. I guess this should be I. Let me change this to img. Enter, I guess final results. Grayscale. Gray. Then we will return final value. Let's run this and see how we do. Okay, 1/3, not bad. Let's see what I got wrong. Is it just upset at me because okay, it seems like it's upset at me. Expected your output. That might be the D type that's being passed in. It's knowing how I didn't start with it. Convert something to a D type. I know how to do it in PyTorch, but in NumPy I feel like it's never really used. So we know, I guess, we're theoretically getting a value D type. Let's just do this. As type. Okay, so we take some NumPy array. And we will do this, and we're taking in the value of D type. And probably should make sure this is NumPy array. Run code, let's see. Do I need to? Hold on. Is missing one required positional argument D type. Oh, it's converting it to D type. Okay. Okay, I think it might be converting it. Let's try something. Here, so, okay, let's try this out. I mean, got the 0 part right, but everything else wrong. Let's see. Data type or float. So here, unit, here it's unit 8, here it's, I'm confused. Let's try this again. Something doesn't work, just keep running it until it magically works. Words to live by. Oh. What did I do? Oh, I guess I returned it as a numpy array, which I guess I didn't specify, but okay, fine. Yay, I got it right. I'll give it a, I don't know if it deserves a like, but it's a solid question for, generated completely by itself. I'm still, okay, let's go through the test cases quickly, because I'm still a little unclear. So, I guess in this case, we're just taking a single pixel, and I'm trying to find out the intensity in terms of grayscale, using Loomis, which doesn't specify in here, just I think says according to human standards or something. Yeah, mimic human, human brightness, and then in the learn section it tells you, oh, this is how we compute human brightness, and then these values. I'm assuming they say they did some study, or there is some study to compute these. Sure, whatever. We'll assume those are right. And we just use this formula to compute the intensity of grayscale for each pixel and apply that to each pixel in the image. Okay, I didn't mind that. At some point I thought I was losing it just because the formatting of the data, but yeah, that was my bad. Okay, let's see. I got a little check mark there. Okay, nice. I don't think I'll have time. Yeah, no, I have to sign off soon. Any questions from the chat? Any thoughts? Wait a little. It wasn't bad. I enjoyed it. Maybe next time I'll try to do this one. This one seems a little more interesting. Oh. So one thing, I guess there's an issue with the question or the test cases if you just look at output and see there's an error. I probably should not even post these questions because I guess we know they're not good. Seems like expected something called your module. Okay. I mean, I guess it could still be useful. You could still like read the learn section and look at the solution and see where it went wrong and understand things, but that's not the ideal case. We're working on improving it. Okay, has anyone chatted? Does not look like it. Okay, thank you everyone. Thank you for joining. Let's see how I could stop the stream, but pretty sure I just go here. Okay, see you on everyone.